Right, so yes, today I'll be talking to you a bit about my PhD project at the University of Leicester using a multi-proxy approach to reconstruct the diets of Cretaceous and Paleogene mammals. So as we're all aware, during the Mesozoic, the age of the dinosaurs were dominating terrestrial ecological niches. And because of that dominance of ecological niches, traditionally it's been thought, like is shown in this nice cartoon from the 1960s, that mammals weren't really allowed to get up to that much because dinosaurs were dominating the scene. So as you can see here, they were reconstructed as small, unimportant, most no bigger than mice and rats, and traditionally reconstructed as just being insectivores and not really doing a lot else. But in the past couple of decades, specifically from finds in the Jurassic, exceptionally preserved specimens, we can see that actually mammals were doing a lot more than has been traditionally thought. So we've got the stereotypical view on the left of terrestrial generalized insectivores, but actually we find semi-aquatic swimmers, we find terrestrial scavenging carnivores, we find fossorial diggers, and several specialized arboreal forms as well. So actually, were mammals doing a lot more than has been previously thought during this time period? The problem is that when we get to the Cretaceous and Paleogene record, we don't have these exceptionally preserved specimens. So it's a lot harder to get at that kind of ecological diversity during this time period. So typically we have dental remains like this, isolated jaws, a few teeth. That might actually be hiding some of this ecological breadth that we see in the Jurassic. So this project is kind of testing that idea from a new dietary perspective using this isolated dental record. The problem being that historically, dietary reconstructions have been quite descriptive, quite qualitative. So here we're using new quantitative approaches, things like dental microwear texture analysis, 3D dental morphology, and also mesowear and stable isotope analysis to kind of unpick whether we can find this kind of hidden ecological diversity in Cretaceous ecosystems. So the first of these methods, dental microwear texture analysis, has been shown among extant mammals. Here we're showing analysis on the bottom right of modern bats to correlate quite nicely with different dietary preferences. So you can see some dental microwear texture surfaces up there on the right-hand side. And you can see that we've got, even among bats that are fairly similar in ecological niche, that there are differences in their microwear. So the top image you can see has much deeper scratches and pits. The bottom image, much smoother microwear surfaces. And the top taxon eats much harder insects with thicker exoskeletons, things like beetles. And the bottom taxon has much softer foods, so things like lepidopterans, butterflies, moths, that kind of thing. And then when we do the similar kind of analysis on fossil taxa, so here we're looking at early Jurassic mammalia forms, we can see similar variation in their microwear textures. So again, we've got much rougher surfaces and much smoother surfaces, possibly suggesting that they were eating similar things to these bats. So we had some eating harder stuff, some eating softer stuff. And based just on their morphology, you might think that they were inhabiting similar niches, but actually when you look at their microwear, you can see this kind of hidden diversity in their ecological niche. The second method that I'll be applying to Cretaceous mammals is 3D dental morphology. So you can take 3D models of the teeth, of their jaws, calculate variables, things like dental complexity, dental relief and slope, and you can use those morphological differences and look at extant mammals, and they actually quite nicely show segregation and differentiation of different dietary categories, and you can use multivariate statistics on those variables and include fossil taxa to identify and assign fossil taxa to different dietary categories. So the grand aim of the project will be to use these different methods, apply them to this kind of isolated dental record in the Cretaceous and Paleogene to test this idea of suppression during the Mesozoic with subsequent radiation out into different niches in the Paleogene after the dinosaurs go extinct. And I'll be comparing the fossil taxa to modern mammals to kind of have this extant framework to help identify the different feeding guilds that the extinct animals might have been occupying. Thank you very much for listening.